Welcome to this demo on machine-to-machine authentication with ADFS as your secure token service. Most authentication scenarios involve browsers and native mobile clients, and in those scenarios we use passive WS Federation or SAML peak protocols, or even the newer OAuth2 protocol. This particular demo is for those of us that have to build non-browser clients. And in enterprise scenarios, these are typically synchronization processes that copy data from one environment to another. So nowadays, when we require these machine-to-machine authentication solutions, we would use something like OAuth2's resource owner password credential grant flow, which is the part of OAuth2 that allows for authentication without human involvement. What I'm about to describe here is for those environments that have passive authentication in place with a browser-based client, typically WS Federation using ADFS, but all of a sudden you get this requirement to support machine-to-machine scenarios where there are no humans involved. Now, although ADFS on Windows Server 2012 R2 supports OAuth2, it only supports the authorization code flow, which requires human interaction and does not lend itself to machine-to-machine authentication scenarios. This is of course an easy fix for those of you that have complete control over the environments on which the products you are working on will be deployed. You just choose a different STS that supports all of the OAuth2 flows, for example, identity server. However, all this, not everyone has this luxury, and some of us have to actually work within the confines of a set production environment where we have no control. And for those of you that fit into this category, this demo is for you. So basically, what we will do is we will build a non-browser client and have it call an ASP.NET WebAPI backend. I'll just use a console app as the client, and this client will request a security token from ADFS using WS-Trust 1.3. And once the security token is received, the client app will set the token on the authorization header as a bearer token and call the WebAPI. The backend WebAPI will just be a default new project, WebAPI project, which requires JOT tokens. So the client will request a security token using plain username, password, credentials. This requires the username and password to be stored somewhere on the client, and this is of course a pretty big security issue. So it's by no means recommended that you do this in your production environment unless you absolutely have to. This demo will hardcode the username and password into the source. Please don't do this in your production code. Alright, let's jump straight into it. Now the first thing we'll do is we'll create the backend project that our non-browser client will be calling. We'll just call it machine-to-machine demo. This is the API that we will be calling. It'll be web API. I'll just quickly change to authentication. I have an ADFS already set up, so this is the link to the metadata for that one. It is on-premise solution rather, and the realm that we'll be using is machine-to-machine demo. Okay, so now that Visual Studio has created the backend, let's see what it gave us. So if we look into the startup auth class, we'll see that the Visual Studio template for WebAPI has used some OWN middleware. Specifically the middleware with the longest method name of all time. It's use Active Directory Federation Services bearer authentication. Which basically says that this backend requires JOT tokens on the authorization header as a bearer token. And that is exactly what our non-browser client will have to supply in order to call any of the endpoints. Now the endpoints obviously are these WebAPI controllers in here. As you can see, the authorize attribute is on there, so any client trying to call any of these endpoints will have to be authenticated. We can pretty much see that if we try to fire up this project like this and try to call the endpoint directly. The authorization has been denied because we don't have the proper authentication bearer token on the request header. We could see this as well using something like Postman trying to call the WebAPI endpoint. As ADFS is concerned, our backend has been registered to have a relying party trust with our ADFS. I've already done this. I won't go through the details. This is something that will already have been done on the environments that you're working on. And for those interested, it's not using any encryption certificates in ADFS, and we are using SHA-256 as the secure hash algorithm. Okay, let's start by creating our non-browser client. So now we come to the interesting part of the demo, and this is where we will create the actual non-browser client that will call the backend web API that we just created before. For this particular demo, we'll just use a console application. In your case, more than likely it'll be some kind of timed process, some hang fire process, quartz process, running maybe under a Windows service. This demo we'll just use a console application. Call it machine client. Now this client will do two things. First of all, it'll obtain the security token from ADFS, and then it will call the backend web API. So in order to do that, we'll create two methods. One request token, so request security token, and one call API. Now the request security token will return a security token, and all of these things like security token, they live in identity model, so we need to add a reference to that. System identity model. And just make the method stubs like so. Okay, so let's focus on requesting the security token. In order to do so, we need to call ADFS endpoint for WS-Trust, which is actually a WCF endpoint. And so in order to call this WS-Trust endpoint, we will use a channel factory and a binding in the same way that we would call a WCF endpoint. And like calling any other WCF endpoints, we would set up a trust channel factory. And this trust channel factory lives in system identity model services. So what we're going to do here is we're going to use the username trust binding, which allows us to pass in a plain text username and password to ADFS as our user credentials in order to obtain the security token. So username WS-Trust binding, and we will use the transport with message as we will use transport and message credentials as our security mode. As you can see here, the username trust binding is a little hard to find. It seems to have disappeared, but luckily for us, Dominic Bayer has ported it to his ThinkTexture identity model project, so that we can still use it. Now we can use the ThinkTexture identity model. I will actually use the ThinkTexture identity model WCF NuGet package because it's a little bit smaller. And like I said before, we'll use the transport with message credentials for our security mode. Now we need to add in the endpoint address. So new endpoint address, which takes in a URI. Now this URI will be the actual endpoint that we are going to use on ADFS to get the security token. Now because we've already said that we're using transport with message credentials, we need to use, and we're using the username trust binding, we need to use a username mixed endpoint on ADFS. So just make sure you can see that. I'll just paste in the endpoint address straight into here. You'll obviously put this into some kind of configuration, but yeah, this is demo code, so we'll just put it straight in like this. As you can see, this is the URL to the ADFS that I've got hosted up on Azure, and this is the WS-Trust username mixed endpoint that will that'll match up nicely with the transport with message credentials and the username trust binding. Okay, so now that we have that in place, we can do a little bit more configuration. I need to set the trust version. Whoops, I think I just did a little bit wrong here. Yeah, it's actually, oops, here, trust version. And we need to tell that we're using the newest WS-Trust. And we also need to set these username, password credentials. And now this is where the hard-coded username, password problem comes in. Okay, so I've already set up a user in ADFS. This user is a test user, like so, with the password of like so. Now that we've done that, we need to configure the request security token message that we're going to send. When we finish, this will actually be a SOAP enveloped message going to the WCF endpoint on ADFS. For the request type, we can use the hard-coded request types of issue, and like I said before, we need bearer tokens. So we'll use bearer, and we need to tell WCF, ADFS rather, what realm this will apply to. And if you remember from before, we used URN machine to machine demo as our realm identifier. Now that we've done all of that, we can actually use our Trust Channel Factory to create the request for the token, and this will return our security token. Need to create a channel and issue, which takes in our request security token, and it has an out parameter which we will not actually use for this demo, but we need to fulfill the API here. And then we've got, now they have the security token, we can return it. Okay, so let's start that up and see what we get. Okay, the security token could not be authenticated or authorized. When you get this, there's a number of things that could be wrong. Maybe there's a token signing certificate registered on the trust relationship in ADFS. Maybe there is something else that's wrong. What I've found in a lot of cases, it's actually very simple. It has to do with the fact that there is, on the wire, there's a missing character in the username. So I'll just demonstrate that for you guys now. If we can start up Fiddler. And then I'll run this again. So Fiddler is a great tool for debugging problems like this. So here you can see the request, this actual SOAP envelope request that's being made to ADFS in order to retrieve the security token. And as you can see, if you look into here, this is the username token. You can see the username and the password in plain text. And in our case, the username is denoted by the domain name, which in my case is Sans Consulting. And you can quite see here, whoops, there's a missing character. And the reason for that is quite simple, but not always very obvious, is that this character here is escaping the T in the username. So to get around that is quite easy. Just put that symbol in front of the string to denote that you want the string as is. Okay, so we'll run that again. And still we have a problem. But in this case, it was merely just the password that was wrong on the ADFS side. So we fixed that. And now we have a security token from ADFS. And we'll try to use that to call our WebAPI. But before that, you know what? I really want to get these hard-coded username and password out of the source code like this, considering a lot of the high-profile breaches today that have been reported lately, you know, with production databases and even source code, production source code being publicly available on the internet. And so, you know, a lot of people would maybe put the username and password in their web config file, but as we've seen, if your production source code is compromised and put on the internet, then everyone will have that username and password. So in order to save ourselves a little bit of hassle and try to be good security citizens here, let's try and get rid of this hard-coded plain text username and password. Now the technique that I'll be using here isn't bulletproof. If the machine is compromised, then you will get access to the username and password, but if the user just manages to snag your production source code off the server and that's all they get with them, then at least they won't get the username and password with the source code. So what I'll do is I'll use a NuGet package that wraps the Windows Credential Manager. This one here. Now this is an open source library. If you don't trust it, obviously you can go and grab the source code, make a fork of it yourself, or whatever. But I'm going to go ahead and trust this guy because the Credentials Manager in Windows it doesn't have any C# APIs available. It's all unmanaged code. So this little NuGet package wraps that nicely. So I'll just put this method in here like so. Now what we're doing here is we're using this Credential Manager to load credentials from the Windows Credential Store. So it allows us to use this Credentials Manager, and now I can add a generic credential. So the Sans Consulting Internet or network address will map up to this parameter here, and then we put in the username and password here. Oops. Now, what should we use for a password? In this case, the best password is one that no one really has. So let's just use, I'll use LastPass here. Can generate a secure password, length 99. Copy that, paste it in, okay, and then go to the ADFS server, do the same thing for the user on ADFS. So I have no way of remembering all those 99 characters, like so. So item 1 will be the username, item 2 will be the password. So, like I said before, this is not bulletproof. Obviously, the credentials are in plain text, like so, and also using Fiddler, the username and password is still in plain text. But at least if someone compromises your production environment, or you have less than trustworthy colleague that decides to dump your source code onto the internet, then the username and password of your integration user will not be part of it. Okay, so now that we have successfully requested a bearer token from ADFS, let's try and call the API using this token. And for that purpose, I'm just going to use a plain old HTTP client. you can use whatever client you want to use on your non-browser client, of course. And now, in order for us to add the authorization header for the bearer token, we'll just use an identity model extension method, courtesy of identity model. Like so. And we need to get this token out of the security token. Now we know that this is a JOT security token that this backend API requires, and herein comes a little problem because we've just asked ADFS for a token, and what we get back is this security token of type generic token. In this case, it's actually a SAML1 token that's being returned. So we need to tell ADFS for our particular purpose backend that we need a JOT type token. We use the ThinkTexture class for that, and JSON web token or JOT token, like so. And since the token that is returned is of type generic security token, we need to do a little bit more magic to get it to become a JOT token. So what we will do is, once we get the token back from the Trust Channel Factory, we can do we'll transform the token to a JOT token. I'll just do that in its own method. And returns a security token. I'll just reuse the reference for that. And create the method. Okay, so the first thing that we want to do is we need to read out the token XML. And once we've done that, we can use one of the security token handlers to convert to the proper type that we require. So the way to read the XML out of the token is we use the token XML string method on the actual security token. So we need to create this XML reader. Create, just use a string reader, and we'll feed the security token dot to token XML, like so. Now we have the XML reader that will read the XML out of the token. And now we need to create a security token handler that will convert the generic token type to the proper token type. What we can do then is use this security token handler collection and create the default security token handlers from the system. And this needs an empty security token handler configuration to work. Like so. And what we'll actually find is that the JOT token security handler that doesn't come out of the box. It's something that we have to add ourselves. So I will I'll just demonstrate that token. Maybe I should use a variable here. Let's try and read the token using the XML reader that we set up before. And we know it's a JOT token that that's been returned. Maybe we should not try to set up the variable twice. Okay, so this default security token handler collection, there's 8 of them, and none of them support JOT. Whoops, let's see. Here we go. SAML, SAML2, Windows, X509, the session security token handler, which you're probably used to. But none of these will actually support the JOT token. So when we do this, the security token is null. So into the token handler collection, we need to add a new token handler. And in order to do that, we need to install yet another NuGet package. A NuGet package. It will be this one here, System Identity Model Tokens JWT. And now we can find the JOT security token handler, and we can add it. Now we can just new up this security token handler. We do not actually have to use the handler collection because we don't actually need the other 8 handlers. But you don't always know that you're getting a JOT token back. So it's always good to have the collection of token handlers, so you can support as many token formats as possible. But for this particular case, we're only really interested in the JOT tokens. So now when we run this, we have a JOT security token, like so. And in here, for instance, you'll see the JOT payload token. I've seen a lot of demos. They like to use this online tool, jwt.io, JWT. Where you can paste in your payload and decrypt your JOT tokens if you need to find any of the information inside. Okay, so now we have the security token. We can add that to the header when we are calling our API. And this is the part where it actually, we know that we need to use the JOT token. Oops, didn't mean to do that. So when we set the bearer token, we need to actually take in the security token here. We need to know that it's a JOT token. Because we actually need to get out the raw data from that token. And then we just put the token string like so. Set the bearer token. This will put the authorization header with the bearer keyword onto it. And now that we've done that, we can actually call the backend. And our API, as I showed before, is hosted on localhost 44300 API values. And read out the content. Oh, we actually need to get the result first. Read as string. As soon as we do that, obviously we need to make this an async method. Like so. And we can probably console right line that. The result. Like so. And so that the console window doesn't disappear on us, we do this. Okay, so we've retrieved the security token. We know it's a JOT security token because that's what we asked for down here. And we've set the JOT security token as a bearer token on the authorization header. And we're calling our backend. And once we've done that, we should get the results back. And of course, the important part here is, which I've forgotten to do, is to start the backend. Alright. See if we have a little bit more luck when the backend is actually running. And there you have it. Value 1 and value 2 is retrieved from the backend in an authenticated manner. So to wrap up, first of all, we created the backend. Now this is something that you, in this type of scenario outlined here, really wouldn't have much control over. And then we created this non-browser client that call the backend in an authenticated manner. There's some details skipped over. I didn't show how to set up the trust relationship with ADFS, and there are some certificates that you will need to install on the client machine for it to work. But all in all, the demo should give you a good overview of how to create these non-browser clients, especially when you're restrained to using the current version of ADFS, and there's no human to punch in the username and password, which is often the case with these sync jobs. So yeah, until next time, have a good one.